I mean, my opinion on it is, in terms of action items, there's a question: should NVIDIA have a response to Mantle? And I think that's unequivocally no. They should, it would be, I think, a horrible mistake if some reason, somehow NVIDIA got panicked by this and made some lower level NVIDIA API. You already have very good low-level access through the GPU extensions that NVIDIA has always rolled out ahead of anywhere else, give you as much performance as you want to trade the inconvenience of doing NVIDIA proprietary stuff on them. Now, Mantle is, AMD has talked many times in the past about close to the metal type architectures, and it only ever became interesting because of their dual console width. If it was just a way to do on the PC, be a little bit more lower level for them, I couldn't have cared less. The landscape does matter, that they have both the major console wins with a similar architecture that you can get on the PC. Developers will be making systems architectural changes that favor those. So I think it's not a stupid thing for AMD to be doing at this point. There are some benefits that they can reap from it. It could have implications for Steam box type things there. But they're probably, if Microsoft and Sony both embraced it, that would be very, very powerful for AMD, but it doesn't look like they're going to, at least Microsoft, from the words that they're mouthing now.
Sure.
So I mean, if I was still doing all of the all of the major technology coding for next gen game stuff, I probably would not be embracing Mantle right now. But there would be days when it would be extremely tempting. But when I would dispassionately step back and look at it, I probably wouldn't come down on the side of saying it's worth the effort there. Obviously, others come to different conclusions.
Sure. There's some good ideas in Mantle. We really liked the idea of having low-level, low-overhead access to the GPU. I mean, if you look back at what's in both DirectX and OpenGL, there's a lot of overhead in those APIs and the multiple layers of them, and the fact that they date back to the old SGI model of hardware rendering, which is very, very different than a modern shader-based programming model that we have now. Where you have potentially unified memory and a lot of processing power available in the GPU and lots of ways of sharing data that go beyond just calling a ton of API functions for every little thing you want to do. So there are good ideas there. I hope that really helps the OpenGL committee and Microsoft shape their future APIs. I mean, if you ask me would I much prefer to have a low-level API for accessing the GPU, the answer is yes, but 5 of them, each for different hardware architectures and vendor and operating systems, absolutely not. That is the wrong direction for the industry to go. And to have yet another API in the PC that's still different than the standard PC DirectX API, and it's different than the OpenGL. The OpenGL ES that exists on Mac and Android and iOS, and it's different than the PlayStation 4's low-level rendering API, and it's different than what Microsoft provides on Xbox. I don't think it's a good idea.
Yeah, so one of the key things about it is, and one of the main reasons we're doing it, is that it's not a replacement. It's not designed that way at all. The idea is that we can solve some of the long-term problems that we've actually been having on really robust performance, consoles type of robust, stable performance. Those are things we can experiment and work with Mantle. We do that with D3D and we do that with GL also, of course. This is another avenue you could see. It's also really interesting of just essentially opening up something that we're quite familiar with already. We've been spending, well, essentially the last 2 years working on the next gen consoles, and the architectures are the same. We're intimately familiar with those architectures, and it's a good fit there, just as John described. And I see, even though we're not done with our work with it, and it's definitely not done yet either to be shipped out, I still see it as a success even right now, actually, just because of these conversations and the amount of things that actually, the amount of developments and the amount of sort of both enthusiasm and even the opposite of enthusiasm, all of the type of, it's been a bit stale, you could say, especially in the PC graphics space. Microsoft, they switched focus for quite some time over to other things, which they probably really didn't need to do. But I think now going forward, it's a really exciting opportunity, both on the PC space and the stuff we're experimenting with Mantle and what we're learning on the consoles, but also on mobile, as we discussed before, of okay, what should be the future graphics pipelines there? There's a lot of movement in all of these things, and it's just good to have lots of different avenues to experiment and actually hopefully deliver concrete value in these things. But I completely agree with both John and Tim that if NVIDIA would do their own API and then Intel would do an API and then Qualcomm would do an API, that's not the future we want to be in. That would be a bad future. That would be a lot of work there. Microsoft and Kronos does play an important part of all of this, and I hope Mantle will be quite influential in many of these aspects also. And what we're doing right now, also specifically with AMD, is just a start.
Thank you, Ryan. Yeah, and you've used the API where we've just read the spec or the marketing materials. What would you say is two questions. What do you think is the cost of, like in man years or whatever, of implementing Mantle support in Battlefield? And what do you think is the ultimate gain on PC? Like, could you try to quantify that?
It is too early to quantify. We've been very busy just making sure our game works overall and actually shipping it out. We're almost done with it. So it's too early to say. We'll have a lot more information in November, mid-November, when we'll talk more about it, and it will be interesting to see. I think it's important also to, one thing that people that are not developers, it can be difficult to understand that when it comes to bottlenecks, it's not like the bottleneck. Okay, we solved this one, we're done, go home, and game runs well. Bottlenecks is like whack-a-mole. You fix one, and then you thought that was the thing, you made that 4 times faster, and then the next bottleneck shows up after 10% of that improvement.
And of course, the biggest issue is that really you have to architect your large-scale vision to take maximum advantage of things.
Yeah.
No API just all of a sudden really makes a dramatic difference on things, because if you build a good game engine to any API, even if you magically made all that API overhead vanish, it doesn't make that much of a difference. It's the possibility of doing. I mean, there's stuff on the GCNs that I'm very excited about. Some of the asynchronous pipeline queues for different things that would be great to take direct control over them. But then that's, you either design for that or you don't design for that.
Yeah, and it will be a gradual approach also of, sure, we're doing Battlefield 4, it's not like Battlefield 4 is only dedicated for a specific API and specific platform. It's a rich game there. You want to work with something and deliver concrete benefits and evaluate and then go forward and see where we are. And hopefully in the future we'll design games based on many of the concepts that we're proving out a lot earlier now than what we can do otherwise. And I think that's actually a good change for the entire industry. Even though people sometimes do get stuck up on like the overall thing, thinking again, the same discussion as I had before of, okay, mobile will replace all of PC. No, that's not happening. Same, Mantle will not replace all of DX or all of DL. That they're complementary. Well, actually, when you use Mantle, it's not complementary, but it's complementary in the actual industry overall. And you want that competitiveness, not necessarily by having 5 different APIs, but having movement. I think that's really, really interesting.
Cool. I think so. I appreciate it a lot.
Can you tell us how much they paid for you to use it?
Well, actually,
Let's leave that one alone.
No. I can answer a couple of questions. They wouldn't have to pay us anything to use it. I've been pitching these type of ideas for many, many years for every single vendor. And it's actually talking just about my own egoistic view of solving my own specific problems, is that we see a lot of stalls, we see a lot of performance gone missing in many areas that we actually want to get that performance. We want to learn how to program a machine on a lower level that has actually a really, really good architecture for that. And I think that's something that will sort of roll out going forward also.
Okay, so it's good as an R&D platform for developers to experiment with. And John, you were talking about the desire to have front buffer access or something like that. A lower level API would be more likely to provide that. I think it's also good if it pushes Microsoft and the OpenGL folks to improve their drivers by realizing that, hey, you can actually achieve a lot more performance on PC with some more low-level techniques. I think it would only be bad if the outcome of this is that now we have to deal with 5 vendor-specific APIs for all of the GPUs.
Yeah. And also the vision for Mantle, well, it can play out many ways. You can't really say for sure. But the vision for Mantle is that well, it can become an open API also. That's something we're completely open for, and that's something AMD is open for also. It's just that that's not the right way to go at it initially. There are those avenues already with Cronus and with DCD. This is
If it
us
weren't
trying
as an
something
open
else.
API, it wouldn't be a low-level API.
Well, actually, I don't fully agree. Sure, you can make an API that's completely down to the level, sort of what you, like on P3, we worked, it was a very, very thin abstraction now, but it was completely specific with that architecture. I do think the way modern GPUs work is quite different from how the DX, or absolutely the GL design was from the beginning there. There are extensions, at least in GL land, where you can access many things, but there are commonalities between all architectures, like bindings, for example. That's an awesome thing that NVIDIA's been working on with GL. That is really the future for all GPUs. And if you ask the different vendors, even vendors perhaps on mobile space that do not have it yet, they agree that it is the future. Well, now I'm talking for all mobile vendors.
Well, yeah,
probably not, but
I mean,
overall,
you know,
it makes sense as a modern design for that. And you see some convergence towards things that are generally good design. And then some people are, some designs maybe will come a little bit later for that. But when it's a great fit for key hardware and it's a great fit for developers, then I think, well, that's the way it will go.
Like my point about unified memory is absolutely here, and we really need to get down to GPUs are just peers on the same memory pool as the CPU, and we really need like documented texture layouts.
And that's another thing, that everything is becoming SoCs also. So even the GPU is a combination of tons of different processors. There's a significant amount of processors, either if it's an NVIDIA GPU or if it's an AMD GPU, there's quite independent engines there. And that's something that's hidden from us now. The GPU is something that you, from the CPU, you prepare your commands, you just give it to them, and it has a driver that tries to figure out which goes where. And that's just generally good design to expose those things a little bit more
Like if you're
closely.
trying to do something picky, like using the hardware video decompression stuff, or then re-encoding there, you have to invent a brand new API to get that captured.
Or even things like compute, for example. Compute is, well, one of the best use cases for compute is for graphics, which is kind of, it feels a little bit weird, but it's not like you want to use it both tightly coupled with your graphics, and you want to use it completely separately that the CPU drives for low latency stuff, and you want to have background tasks that have can have really high latency and run in the background and just eat up whatever vector units that are free on your GPU. That's also generally good design for any
even
type
in
of
the
system.
GPU space, I'm hitting on these issues where I want GPU task scheduling, and we have no concept of prioritization between GPU SKUs, where we need to be able to specify time slices and priorities, and it's down to being a CPU scheduler for a finite resource.
And it will likely take quite a lot of time until we find a convergence to a definite model there. But in the meantime, it's good to have a couple of models, both from hardware and from software, sort of competing or being tested there, and see what comes out of all of that. Because I do think there will be quite interesting convergence there.